Hey everybody, this is just going to be a short video on rational functions. For each rational function that we have, we're going to find its zeros, its vertical asymptotes, horizontal asymptotes, oblique asymptotes, point discontinuities, and finally we're going to graph the function and see what it looks like. So what is a rational function? Well, a rational function is just a function where you have a polynomial on top. Let's just call it a of x. That'll be the numerator or the top of the fraction. And then on the bottom of the fraction, you have another polynomial. Let's say b of x. The only trick is you can't let the denominator be 0. So I'm going to write b of x cannot equal 0. Because if it was 0, you would actually be dividing by 0, and that's no good. So we're going to be using this definition of the rational function to help us find all those characteristics of a rational function. So the first thing we want to do is we want to find all the zeros. And the way we do that is we're going to set the top equal to 0. The top of the fraction is x minus 1. So I'm going to set that equal to 0 so we can find out what our zeros are going to be. So we get x minus 1 equals 0. So to solve this equation, I'm going to add 1 to both sides so we can get x by itself. Once I add 1 to both sides, I get x equals 0 plus 1, which is 1. So x equals 1 is going to be our 0, and we can write it as 1 comma 0. And since we can also call this an x-intercept, we're going to let the y-coordinate be 0 for all of our zeros. So that's how you find the zeros. You let the top be equal to 0. The next thing that you want to do is you want to find the vertical asymptotes. I'm just going to abbreviate that as VA. And basically what you want to do with vertical asymptotes is you want to set the bottom of the fraction equal to 0. So now we're going to take the bottom of the fraction and set it equal to 0. So I get x minus 3 equals 0. And I'm going to solve this equation just like I did the last one. I'm going to add 3 to both sides. And hopefully everything will come out well. I get x equals 0 plus 3, which of course is 3. So that's going to be my vertical asymptote. Now, what we know about rational functions is they also have horizontal asymptotes, sometimes. There are actually 3 rules that you need to know about horizontal asymptotes, but I'm just going to go only over this one right now. So what we want to look at now is we want to look at the degree of the numerator. I'm going to write that as DEG, degree of a of x. And we need to know the degree of the denominator, DEG b of x. Now the degree is just going to be the highest exponent. So we need to figure out what's the highest exponent on top and what's the highest exponent on the bottom. Well, the exponent for an x is just going to be 1. So we know that the degree of the top is going to be 1. We know that the degree of the bottom is also going to be 1. So it turns out that these 2 degrees are going to be equal. So if that's the case, we're going to take the leading coefficients and put them on top of each other. So for our horizontal asymptote, we're going to take the leading coefficient of the top, put it on the top of the fraction. So the leading coefficient over here is going to be, well, there is no leading coefficient, so we just let that be 1. And then we have 1 over 1. And of course, 1 divided by 1 is just going to give us y equals 1. So that's going to be our horizontal asymptote. Now, we don't have any point discontinuities because none of the factors get canceled on the top and the bottom. Usually you can factor the top and bottom and cancel out common factors, but since there's no canceling that's taking place, there's not going to be any point discontinuities. So there's not going to be any point discontinuities, at least with this rational function. So I'm going to abbreviate that as PDs. And then the last thing we need to worry about is oblique asymptotes. Oblique asymptotes really only come into the picture when the top degree is one bigger than the bottom degree. And since that's not the case for this one, there's not going to be any oblique asymptotes. So we don't have to worry about those either. Okay. So what's the last thing we have to do? We need to graph the function, right? So I'm going to go over to Desmos and I'm going to graph this function. So we have f of x is equal to, now normally I put the top in parentheses and I also put the bottom in parentheses. So I'm going to put the top in parentheses. It was x minus 1. And then I'm going to do my division symbol so I can get the bottom of the fraction in there. The bottom of the fraction was x minus 3. I'm also going to put that in parentheses. And now we have our graph. So this is the graph of a rational function. We know that it's going to have vertical asymptotes, it's going to have horizontal asymptotes, and it's also going to have zeros. And we want to identify those as well. So going back to our slide, our zeros were 1, 0. So I'm going to plot that point on Desmos. I'm just going to plot the ordered pair as 1, 0. And notice that point is on our graph. It's right over here. And notice that this is the x-intercept. That's where the graph is going to cross the x-axis. What we also need to graph is we need to graph our vertical asymptotes. So going back to our slide, we know that the vertical asymptote is going to be x equals 3. So I'm going to graph that line on Desmos. I'm going to graph x equals 3. So I'm just going to type in x equals 3. I get this vertical line down the middle of the screen. And what I'm going to do is I'm going to change the color to blue and I'm going to make it a dotted line. Because typically when we do asymptotes, we draw them as dotted lines. So this is going to be the vertical asymptote for this function. Notice that the graph is going to approach the vertical asymptote, but it never actually crosses the line. That's very typical for asymptotes. Once you get close enough to the asymptote, the function is going to start going up and going down at a crazy speed. So that's how the vertical asymptote works. We also have horizontal asymptotes that we found, right? So going back to our slide, we know that our horizontal asymptote down here was y equals 1. So I'm going to graph that as well so you can see what it looks like. So going back to Desmos, I'm going to graph y equals 1, and I get this purple horizontal line in the middle of the screen. And what I'm going to do with that is I'm going to change the color to blue once again, change it to blue, and I'm going to make it a dotted line. So you can see that the graph approaches the horizontal line, but never actually crosses it. So this is what a rational function does. It might have vertical asymptotes, it might have horizontal asymptotes, it might have zeros. They may even have oblique asymptotes and point discontinuities. But hopefully this example is just here to help you, and hopefully it did. So I guess that's it. Have a great day. Thanks so much for watching.